Let's look at lesson 79. We're going to be talking about symmetry. And as we do, realize that we just finished up talking about triangles. We talked about, remember, different ways to classify triangles. We talked about naming them according to their angle. And we looked at right, acute, and obtuse, if you remember. And we looked at classifying them according to their sides. So we looked at equilateral, we looked at isosceles, and we looked at scalene. So if you don't recall those different names, you might want to look back at 78 and just review just a little bit, okay? All right. If you haven't done the warm-up, go ahead and do that now. You can pause the video and do that, and just pay attention to the note here that they are mentioning that allows you to do some of the calculations in your head. So they're just saying that you can rearrange numbers, especially when you're adding and subtracting. You can rearrange numbers to make the computation easier. So just pay attention to that and then practice these here, and we can talk about any problems you may have. All right, in the new concept here, we're going to talk about the idea of symmetry. So symmetry is the concept that there are two equal halves. So an object, if you divide it straight down the middle, is going to have a right and a left side that if you pair them together, they match up perfectly. There's some terms here that you might want to be aware of just so that you can understand the vocabulary. So reflective symmetry maybe is the entire phrase, or just symmetry for short. And we should be able to find a line of symmetry. That line of symmetry is basically what you would cut the object down right through the middle in order to get two equal halves. You can also think of that line of symmetry kind of like a mirror. So that line of symmetry can be like the mirror, as if one half is looking in the mirror and sees itself and forms the other half. All right? In this example, it's saying which of these polygons does not have a line of symmetry. So if it doesn't have a line of symmetry, you would not be able to divide it into two equal halves. This one, you can draw a line of symmetry here. You could also draw a line of symmetry like that. The triangle, you could draw a line of symmetry like that. But here, for object C, there is no way to draw a straight line and divide this into two equal halves. In this case, they're looking at different letters. So letters, if they're drawn in a certain way, can be sometimes divided into two equal halves. So you'll notice here that the letter C, you can draw a horizontal line. That horizontal line will break that C into two equal halves. And H has vertical symmetry as well as horizontal symmetry. The A has vertical symmetry. The I has both vertical and horizontal symmetry. The R, though, there is no obvious symmetry there. There's no vertical line you could draw or horizontal line you could draw in order to cut it into two equal halves. So here in a little bit of the some practice, it says copy each figure and draw the lines of symmetry. So you're just looking for a vertical line or horizontal line, or I suppose it could be a diagonal line that would cut the object into two equal halves. All right? Basically, the idea is that if you were to take the object and fold it over that line of symmetry, the two halves will match up perfectly. So here, you could draw a vertical line of symmetry. Here also a vertical line of symmetry. Notice that in C, you have an equilateral triangle. That equilateral, it's also equiangular, meaning all the angles are equal. They would be 60 degrees. All the sides are equal in length. You could actually draw a line of symmetry 3 different ways for that problem, okay? This letter, you can draw a vertical line of symmetry, a horizontal one. The Z doesn't have really any line of symmetry. The W, you could draw a vertical line of symmetry there, and this object doesn't look like it has an obvious vertical or horizontal line of symmetry. Okay? So that concludes the lesson. Just look for ways to divide an object into 2 equal halves. If you want to pause the video here and jump into the problem set, and then come back, and I'll just make some comments about each of the problems as we go through all 30 of them together, okay? And then we'll deal with any problems you have. All right, in the problem set, we're just going to go through these quickly, and I'll make some comments. Hopefully the comments will be helpful. This is a circle graph, and dividing Dan's day, his hours that he spent in his day, into different activities. So we just need to be able to read this circle graph and be able to collect the data and the information from it. Okay? What is the total number of hours shown in the graph? Well, the total number of hours, what you're going to have to do is you're going to have to add up all of the individual hours for each part, each piece of the pie graph or the circle graph. Okay? What fraction of Dan's day was spent watching TV? TV, you have to find that particular part of the pie graph. It's 1 hour, so it's 1 hour over the total. So after you found the total from number 1, that total is going to go there in the denominator. If Dan's school day starts at 8:30 a.m., what time does it end? So if it started at 8:30 a.m., then you're going to have to add on. You already calculated how many hours are in his day. Then you're going to have to add on however many the total hours are. Okay? Add on those total hours starting at 8:30. So use your timekeeping ability in order to figure out when his day ends. Which 2 activities together take more than half of Dan's day? More than half. So you want something that is going to exceed half of the circle. So you really don't have to add up all the numbers. You just have to look at the 2 portions of those particular events and recognize that they're going to be more than half. Okay? So if we look at our options here, sleeping and playing. So sleeping and playing, if you add those together, that's not going to be quite half. It's going to be less than half. School and sleeping, it looks like definitely school here and sleeping, so you can see that that is going to be more than half. Okay? School and homework, those 2 sections, if you ignore that middle, you're still not going to have 2 pieces that are going to be more than half. School and playing, again, those 2 sections are not going to be more than half. So your answer there is C. Okay, let's move on here. 1/5 of the 60 eggs were placed in each box. How many eggs were placed in each box? So you'll notice that they took the entire big container and they divided into 5 smaller ones. And so if you understand that concept and are able to even draw that, you're going to have 60 eggs and you're dividing it into 5. So for this one, you're going to take 60 divided by 5. And you can do that, think of that in many different ways. 60 over 5, 60 times 1/5. So there's lots of ways to tackle that, to figure out how many are in each. If you divide them equally, how many is going to be in each of the tinier boxes. This one looks like one we did in the last lesson. So if this is the halfway point, that's going to be 2,500. So this is the one that's going to be closer to 2,250. Estimating the sum. This is a powerful skill to be able to estimate. So 427, 533, 764. So you want to round those, each of them to the nearest 100. So 427, you would round that down to 400. 533, you also would round that to 500. And 764, you're going to round that up to 800. And then just add all those up. 4 plus 5 plus 8. So 4 plus 5 is 9, plus 8 is 17. So you can have 17 and then 100. All of these are hundreds. 1700. What fraction of this set is not shaded? So not shaded would be all of these here that don't have the circles shaded in. You're first going to have to find out how many total are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is all out of 10. And 3 of them are shaded, so 7 are not. Always reduce this fraction if you can. In this case you can't, but you always want to reduce it if you can. Okay, 42 oranges could be shipped in one box. Luther had 30 boxes. How many oranges could be shipped? If you put 42 oranges in one box and you got 30 boxes, well, hopefully you realize that you're going to multiply those two numbers to find out the total number of oranges. 5 apples will fit in one small box. Hannah has 145 apples. How many boxes does she need? So 145, you're going to take 145 and you're going to divide them into small boxes. 5 in each. You can put 5 over here in this box. You can put 5 in this box. You can put 5 in this box. You can put 5 in this box. So obviously, you're going to take this 145 and you're dividing it into 5s. You're dividing, how many times is it you're going to be able to divide this by 5? So 145 divided by 5. And that's going to tell you how many boxes you're going to need. Perimeter, this is a square. So the square, all 4 sides are equal in length. So all of these are 5. So you're just going to add up 5 plus 5 plus 5 plus 5. Of course, you can just take 4 times 5 if you want and get the same answer. Draw the capital letter E rotated 90 degrees clockwise. So you're going to rotate this 90 degrees. So you can just think of even a single point here. If you take that single point and you rotate it 90 degrees, that single point is going to be here. And then from that single point, you can draw the rest of it. Okay, so the idea is the E now is going to be on its back, sort of. Okay, I'm going to let you do all of these that are computations and assume that you can do those. Take your time with these. These are great skills that you are going to need for the rest of your life, doing multiplication, subtraction, addition, division, all of those. So don't just rush through those. You make sure you're taking some time and really practicing those. And then better you get at those simple computations, the easier this class will be and the easier future math classes will be. Okay? Let's do pause here and look at number 23. 4 times something. Remember I said that every equation, this is an equation, has an equal sign, is asking you a question. This question is 4 times what is equal to 160? Well, another way to think of that is if you say, let's just use some really simple numbers. If I say 2 times 5 is equal to 10, well, I know that another way to think of that is 10 divided by 5 is equal to 2, or 10 divided by 2 is equal to 5. So if I'm multiplying two numbers together, I know that if I take the product, which is 10, and divide by any of these numbers, 2 or 5, I'll get the other number. So if I take 160 and divide by 4, I will get the unknown number P. Okay? Here's some good practice with square roots. So you should know these square roots very easily. You should know the square roots of numbers that are going to give you, that are perfect squares. 64 is a perfect square. Square root of 64 is 8. Square root of 16 is 4. And then make sure you always reduce that. Okay? I'll let you do this one. 26, make sure that when you do this, you do the exponents first. So it's 10 times, and then in parentheses, you're going to have 6 squared, which is 36, and then 2 cubed. That's 2 times 2 times 2, 3 times, which is 8. Then add what's in parentheses, and then the final thing you do is you will multiply by 10. Because these parentheses are telling you do whatever's in this group first. And in the group, you have to do exponents before you add. Okay, find the perimeter of this rectangle. Perimeter, you just add up all the sides. And since this is a rectangle, the opposite sides are going to be equal. So add up all these sides, they're all in centimeters. And then once you get the answer in centimeters, you need to convert it to millimeters by multiplying by 10. There are 10 millimeters in 1 centimeter. So once you find the answer in centimeters, you need to multiply it by 10 to get the number in millimeters. And let's see, what number do we have here? So you first have to figure out what is the value of each division here. So it looks like we're counting by 1, 2, 3, 4, 5. We're counting by ones. So now here's 0. If we go down, -1, -2, -3. Okay? So that arrow right there is pointing at -3. If Micah spun completely around twice on a skateboard, how many degrees did Micah spin? Well, if you spin on a skateboard, if you go around once, that's 360 degrees. If you go around a second time, that's another 360 degrees. So 360 and another 360 is going to be a total of 720 degrees. If you just spin around halfway, that's 180. Okay, a full circle is 360. And which of these letters does not have a line of symmetry? So we can draw a vertical line here. Yes, symmetry. This one, probably because of that little tail on that U, there's not going to be any symmetry there, because if I divide it vertically here, there's not an equal little tail over on the other side. So this one does not have any symmetry. V does, yes, vertical, and W does, yes, a vertical line right there. Okay? So I hope this was helpful. Keep up the good work, and let me know if you have any questions.